The objective of today's lecture is that we want to start lecture series on NPTEL on the topic of dielectric resonator antennas. I'm Professor Rajveer Yaduvanshi from Netaji Subhash University of Technology, Delhi. DRA, the full form of DRA is dielectric resonator antennas. We are well familiar with the term antennas. These are basically devices which are being used in wireless communications systems for converting electrical energy into EM waves and vice versa. So, for any wireless system, the antennas are crucial components and they are being used in almost all wireless systems. The wireless systems may be radio communication, may be radars, and if we go more precise, we can say the sonar. In wireless systems, we have seen the antennas being used specifically for broadcast, for receiving these TV as well as radio signals. We have seen bulky antennas which are generally made up of metallic part. But I'm talking something different which is unconventional, and it is not made up from material, rather it is made from dielectric materials. Why should we design dielectric material antennas? Those are known as dielectric resonator antennas. Reason being, the metallic antennas at higher frequency offer huge loss, and at higher frequencies they are unable to provide the efficiency. In dielectric resonator antennas, we have capability that they can operate right from microwave frequencies to terahertz frequencies, and they offer higher efficiencies, even better than 90%, which was not possible in case of metallic antennas at higher frequencies. Now, in dielectric resonator antenna, we have one more advantage, that the metallic antennas which are of patch nature, they have limitations of limited aspect ratios, whereas in dielectric resonator antennas we have two different aspect ratios, and these aspect ratio give designer a wide flexibility which was not possible in case of patch antennas. So one important parameter is that they are efficient. The second parameter is that they give us two different aspect ratios, and these aspect ratios will help us to generate higher modes than in patch antenna. Only limited modes used to be generated, whereas in dielectric resonator antennas we are capable to excite not only a fundamental mode but higher order modes. Again the question will come, what is the use of these higher order mode excitations which was not possible in patch antennas? The answer is we use these multiple modes or higher order modes by manipulating. Either we can combine them or we can split them. In communication applications, there are different applications. Either we want to operate at single frequency, or we want to operate multiple frequencies in one particular band. It means by splitting those resonant modes at certain intervals, our antenna will be capable to deliver different bands, and these bands can be used for different services. It means if we are able to excite multiple modes, we are able to cater different services on each mode using only one antenna, which was not possible in case of patch antenna. The second scenario, that if we want to have huge amount of bandwidth, that is bandwidth, wide bandwidth, or sometimes enlarged bandwidth, so that is also possible if we are capable to excite multiple modes. So by manipulating these modes, we can either merge these modes into single bandwidth, and we can achieve by merging these modes in particular band, we can achieve higher bandwidth, which was not possible in case of patch antennas.